Welcome to the 2024 Subseasonal Seasonal Applications Workshop. Thank you to the organizing committee from the Office of Science and Technology Integration and Weather Program Office, Environmental Modeling Center Director, and Climate Prediction Center Director for putting together an amazing 3-day lineup of sessions and speakers. Also, to the NOAA Center for Weather and Climate Prediction for hosting, and to all of you for attending and engaging on this important topic. We've come a long way since decades of work, starting with ENSO and MJO observations and simplistic models for finding sources of predictability for S2S phenomena. We now have statistical, dynamical, and AI and machine learning models to predict the future. Each stands on the shoulders of data catalogs and advancements in observation and computational developments, driving towards improving prediction skill. But we cannot lose sight of why this all matters. S2S science has broad applications across society, both reducing the risk of damages to lives, livelihoods, and property, but also increasing opportunity, innovation, and productivity if wielded effectively. My own research has shown that winter outlook and ENSO outlook can literally move financial markets, reducing risk exposure in the billions of dollars. Even in a steady-state climate, there is a demand for S2S products. From water management and agricultural applications in the U.S. to meet our basic needs for survival, to supporting energy security, transportation, and the move of global commerce. These predictions are critical. At NOAA, we even work with agency partners on diplomatic applications using predictions to inform seasonal locust outlooks in Africa and heat, drought, and food security forecasts worldwide. Climate change and actions to respond to it are increasing the need and urgency to develop sound S2S science and speed the transition to operational S2S products and services. Society was built for a climate that no longer exists, with the shifting probability and magnitude of extremes, leaving us vulnerable. If planned in advance, S2S predictions can set into motion actions to reduce impacts or turn rare events into opportunities. Something water managers in the American West have highlighted for me in their efforts to recharge groundwater and efficiently allocate every last drop of surface water. This urgency is also felt globally with Early Warnings for All, an initiative launched in 2022 by the United Nations Secretary General. This initiative aims to ensure that everyone on Earth is protected from hazardous weather, water, or climate events through life-saving early warning systems by the end of 2027. At NOAA, we are engaging with partners at the State Department on the President's Emergency Plan for Adaptation and Resilience, or PREPARE, to strengthen global resilience against climate impacts by providing critical environmental data and support to vulnerable nations, including work to expand early warning systems in Africa and building resilience in island nations. This partnership ensures that communities worldwide have the resources and information necessary to adapt to and mitigate the effects of climate change. We will not only continue to explore the physical, biological, and chemical sciences limits of S2S, but increasingly expect work at the intersection of social sciences. For example, back in May, I laid out a framework at Treasury on how S2S predictions can influence macroeconomic forecasts in the US and abroad. There is incredible demand for the work you are doing, and I only expect it to grow. Thank you all for participating in this workshop, and please hasten the transition of the important research you are conducting into new products. The world needs you.